Hello everyone, welcome back to our Python programming course. In the previous lecture, we learned about relational operators and logical operators. Those operators help us to compare values and combine conditions. Today, we are going to learn another important category of operators called assignment operators. So, before starting that, let me ask you a simple question. Suppose I want to store the value 100 in a variable called named salary. Suppose yes, salary is equal to 100. Here, the value 100 is assigned to the variable salary. This operation is called assignment. But the Python provides more than just the equal to operator. So currently, suppose here salary is 100 and I want to increase it by 20. Then I will write salary plus 20. So this is how if we want to increase 20. So we have Python provides a very shorter and cleaner way. So instead of this, we can write like salary. Instead of this, we can write like this. So actually, both statements produce the same result. This makes our code easier and easier to read and easy to write. So this is the short form of the second line. So this is why we will use actually assignment operators. So I will give you a simple definition of assignment operators. Assignment operators are used to assign values, to variables or update the. So assignment operators don't compare values. They don't make decisions. Their job is to simply to store a value or update an existing value. So we'll use assignment operators in almost every Python program, especially when working with loops. Or when working with loops, we usually use. So let's see the type of assignment operators. These are the types of assignment operators. So now Python provides you several assignment operators. Let's see. First one is the basic assignment operators, and remaining operators are called compound assignment operators because they perform a calculation and assign in a single step. So first one is assignment of assign operator means let's start with the simple assignment operator. Suppose the symbol is equal. So it stores a value inside a variable. Usually at the starting we wrote suppose name is equal to your name. Let's print name. That is first one. And Okay. Let's see the second operator, plus equal to. Here, actually, I have done before. Suppose, suppose your score is 100. So if someone said increase it to 50, increase 50. So let's print both salary and score. So it increased by 50 and salary also increased by 20. This is how this second operator will work. Now let's see the third operator, subtraction assignment operator. This is third operator. Suppose in your wallet money is around 5,000 so it decreased by 1,200. This is how subtraction assignment operator will work. Now let's see the third operator, fourth operator. This is division assignment operator. Suppose wallet is equal to 1,000. 50. So this thing, this is how this division operator will work. Now next one is modulus assignment operator. So I have told you before, modulus is for reminder. We'll find reminder. Suppose something is equal to 17. Now, now let's print this. Print now. So it will give us a reminder. So usually modulus operator will give us a reminder. This is how modulus assignment operator will work. Now next, let's see with floor division operator. So actually floor division performs floors and stores the integer results. Suppose students is equal to, there are 105 members. Let's see students equal to, so we got output 10. This is how we'll use floor division. It will remove the decimal point. In division, it will give with a decimal point. In floor division, it removes the decimal point. So the last one is exponent assignment operator. Whose num is equal to 2. So 2 power 4 16. This is how exponent assignment operator will work. So this is about these are the types of assignment operators. So I think we'll practice some questions on this. So next we can move with bitwise operators. So let's start with bitwise operators. Until now, we have worked with numbers directly such as 10, 20, 30. But internally, computers do not understand decimal numbers. Computers only understand two digits, 0 and 1. This number system is called the binary number system. Bitwise operators works directly on these binary values. So these operators are mainly used in low-level programming or any other languages. So I will give you some types of bitwise operators. And operator we have learned before on logical operators. So this is OR operator, and this is XOR operator. This is not operator. This is left shift, and this is right shift. These are the operators. Now, first one, so in this, let me create a new file. Suppose A is equal to 5, B is equal to 3. So let's print A and B. So it prints 1. This is how, let's see. So for binary representation of 5, 5 remainder of 5. So for 5, 1, 0, 1. For 3 equal to 0, 1, 1. So answer will be 0, 0, 1. I think we know these calculations for 1, 1 will be 1, 0, 1 will be 0, and 1, 0 will be 0. So finally, the number here is 1. This is how bitwise operator. This binary number is is for 1. The binary numbers are 0, 0, 1. Let's see with OR operator. Suppose A is equal to 5 and B is equal to 3. This is how binary numbers work. So binary representation for 1 is actually 0, 1, 1, 0, 1. And for 3 is 0, 1, 1. So the result will be triple 1. So for 7, binary representation is triple 1. So this is how bitwise operators will work. Like this for OR operator and NOT operator. For NOT operator, suppose A is equal to 5. So this is the most confusing operator for usually. This is about bitwise operators. Let me see whether it's recording or not. So next topic, let's start with membership operators. So bitwise operator, usually we covered before also. We have learned about n or n, x or not. So now let's start with membership operators. Membership operators are one of the most practical operators in Python because they are used to check whether a value exists inside a collection such as string, list, tuple set, or dictionary. Suppose I'll give you a simple definition of membership operators. Membership operators are used to check whether this is the simple definition of membership operator. Membership operators are used to check whether a particular element exists inside a collection or not. Means Python provides two membership operators, in and not in. The result is always either true or false. So let's see the types of membership operators. First one is in operator, and one is not in. So now let's discuss with in operator. Its in operator checks whether an element is present inside the given collection or not. Suppose, for example, let me create a new file. Suppose name is equal to Python print p in name. It will print true. So p is present in Python. So this is how in operator will work. Python checks whether is p present inside Python. So it's yes, therefore Python returns true. Let's see another small example. Suppose some so banana is present in fruits in this list. So let's say it prints true. So it prints true. So Python checks whether this banana exists in the list. Since it exists, so our answer becomes true. This is how this in operator will work. So now let's see with not in operator. Suppose name is equal to again Python. So J not in name. I think this is also true. So J is not present in Python. So Python checks is J present inside Python. So no. Therefore, it becomes true. Suppose if I write J name, it will return false. This is how not in operator will work. Let's see with a list example. Suppose is equal to Singapore as a way to print Hyderabad not in cities. So this is true. This is how not in will work. Let's see with a one input type example. Suppose suppose in online shopping available sizes avail size is equal to let's take a input of any variable like price is equal to input. Suppose size to small. I have written here small s. Let's print again. Suppose if I give capital S. So this S is present here. So it will return true. This is how this in operator and not in operator will work. So I will discuss briefly about this membership and we will close this topic. So in operator checks whether a element exists and not in operator checks whether a element does not exist. So now let's go with next topic, identity operators. So identity operators in Python are another small important topic in Python. So unlike relational operators that compare values, identity operators compare memory locations or object identity. So here, let's see the definition. First, I'll give you a simple definition of identity operators. Identity operators are used to check two variables refer to the this is a simple definition for identity operators. So there are two types in identity operators, is and is not. I will write here. First one is, second one is not. These are the two types of identity operators. So in identity operators, the result is always either true or false, like membership operators. So let's see. Let's start with is operator. It returns true if both variables refers to the same object. Suppose let me create a new file for this. Suppose if I give A is equal to 10 and B is equal to 10, so A is B. So it returns true. So here Python stores both variables with the same value. And in many cases, Python internally uses the same memory object. So here A is B. So it returns true. Suppose we use a list program. Suppose x is equal to x is 5. It returns false because for here in list the values are the same, but Python creates two separate list objects. Therefore, their memory locations are different here in list. So it returns false. Suppose let's see another. I will give a similar example of this. Suppose x is equal to 1, 2, 3. Let's see this same. And now I will write x is equal to y. So now it prints true because here we are not creating a new list. Means x is equal to instead of y is equal to x means both variables point to the same object here. So x is y means true. It will return true. So this is how is operator will work. So now next let's see with is not operator. Suppose a is equal to 20. So here it returns true because although both lists contain the same values, but they're stored in different memory locations. So if we wrote there A is B means it will return false because different memory locations. But instead of that, we have written here A is not B. So that's why it gave true. Suppose I take name1 is equal to Python Java. So it returns true. This is how this is not operator will work because Python is not Java is true. If I wrote instead of Python, return false because we have written there is not operator. So this is about is and is not operator. Let's see one small difference because before we have learned about compare values means double equal to. Here we learn about is compares memory location. So the difference between that double equal to and is double equal to compares values and is operator compares memory locations or object identity. So this is about I will give a small example for both the double equal to and is operator. Suppose A equal to and B equal to Let's see the difference. Because A double equal to B and A is B. So double equal to returns true because values are equal. But is returns false because memory locations are different. This is the difference between the double equal to and is operator. Suppose suppose one real life example. Let's see. Data equal to none. Print data is none. So it will return true. See, this is actually one of the most common uses of this in Python. So this is about this identity operators. So let's briefly talk about this. Is operator checks the same object, means memory locations. Is not object checks different objects, and double equal to we have learned before. So it checks the values. So this is about identity operator. So our next topic is operator precedence. So our next topic is operator precedence. And so this is a small topic but important topic because of this there are some unexpected answers in calculations. Let's see about this. So before that I will give you a simple definition of this. So operator precedence means the order in which Python executes so this is the simple definition of operator precedence. So actually, why do we need operator precedence? Suppose if our result is, let's make create a new file. So here the answer is 20 because actually if you do like 10 plus 15, 15 into 2, 30, we'll expect 30. It's wrong because Python follows precedence. First, it follows multiplication, later, it follows addition. I will give you a small operator precedence. So, first, it follows this next power, next step, addition, division, floor division, and modulus. Next, logical operator, not, and and at the last, or operator. This is the order. So this is the order for operator precedence. In this order, we will calculate everything slowly. Let's see with the example. Suppose let's print 5. So I think the output will be 16. Yes, because as we have learned here, brackets have the highest priority. So first 5 plus 3, 8. So 8 into 2, 16. This is how to work. Now let's see another example. Suppose let's think 2 plus 3 into 4. Let's run this as we have learned here. First, we have to give priority for power. So 4 power 2, 16. 16. Next, we have to give power for multiplication. So 16 into 3, 48. So later, 48 plus 2 is equal to 50. So the answer will be 50. Yes, this is how we follow. And I gave here operator precedence order. Let me see whether it's recording or not. Yes. So this is the operator precedence, and this is about operator precedence. So this is the order we have to follow for operator precedence, and this is enough, I think. So I will briefly explain about this. So first we have to give highest priority for that brackets. Next, that power. So at the third position, we have to give for multiplication, division, flow division, at the last modulus. So this is all about operator precedence. In today's lecture, we have learned about operator precedence, identity operators, membership, and bitwise, and assignment operators. So from next class, we will start with if if statement, if else statement, if elif else statement. This is the most important, major important topics. So thank you for watching this video. Let's continue with our next class. Thank you.